Good day to you all. Welcome to Maths Global Learning Hub at Mr. T. In today's lesson, we're going to look at the application of compound angle identities. If I look at the first part here, this one is reduced, but I must do some reduction here. So I'm going to write here cos x plus 379 degrees. Because I have an angle here which is greater than 360 degrees, I must subtract 360 degrees here. And if I do that, I'm going to get and if I look at the last part here, it says cos x plus 244 degrees. I can write this as and my final answer will be negative cos x plus 64 degrees. I can now proceed to do the substitution. The first part stays the same, sine x plus 64 degrees times cos x plus 19 degrees. That is the answer that I got when I did reduction there. Then plus sine x plus 19, but I can see here I've got a negative, and this negative here is going to affect this positive here. But let me just substitute. And then here I've got and then I'm going to get a negative, and the positive gives me a negative. And when I look at this part here, I can rearrange. So this one stays the same. Minus cos x plus 64 degrees sine of x plus 19 degrees. And if I check here, I can see that I have compound angles here. I can check the pattern here. I have got an S here, and I have a C, and here I have C followed by S. And this angle here is my A, and this one is my A. This angle here is my B. This angle is my B. So I can write this as x plus 64 degrees minus x plus 19 degrees. And if I simplify, I'm going to get sine x plus 64 degrees minus x minus 19 degrees. And then if I simplify further, I'm going to get sine of 45 degrees. And remember, sine 45 degrees is a special angle, so I can write my answer as square root of 2 over 2. If I move on to the next part here, I can also do my reductions first. I prefer to put my reductions aside so that I don't confuse my work. And this is going to be cos of 360 degrees minus 65 degrees. And my final answer here is going to be cos of 65 degrees, because this angle is in the fourth quadrant. If I move on to the next part here of my reductions, this is an angle that is in the second quadrant, so it's going to give me sine 180 minus 65, and I'm going to get sine 65 degrees. And then the last part, it says cos 205 degrees. And if I do this one here, I'm going to get cos 180 degrees plus 25 degrees. And my final answer is going to be negative cos of 25 degrees. Then I can proceed to do my substitutions. This part here, it gave me cos of 65 degrees minus sine 65 degrees, and then minus cos of 25 degrees. I'm going to get here cos of 65 degrees minus a minus, and the minus is going to give me a positive. So I'm going to get here sine of 65 degrees times cos of 25 degrees. If I check for the pattern for the compound angles, I'm going to see that here I've got a C, here I've got an S, and here I've got a C here. So I'm going to use co-ratios to change this part here to sine. So I'm going to write here cos 65 degrees, cos 65 degrees plus sine of 65 degrees times sine of 65 degrees. If I convert cos 25 degrees using co-ratios, and then I can now apply my compound angles, and I'm going to get cos of 65 degrees minus 65 degrees, and this is going to give me cos of 0 degrees, and my final answer is going to be 1.